What I want to do is I want to make the entire denominator my u. So u is equal to x squared minus 8x plus 41. The derivative of this is 2x minus 8. If I solve for dx, I get du over 2x minus 8. If I plug this in, using u substitution, I plug in my u and I plug in my dx. Everything else I leave the same, so that gives me 2x plus 2 on the top, u on the bottom, times du times 2x minus 8. And I ask myself the question, do my x's cancel out? I mean, maybe if I factored, they would cancel out. Let me see. If I factored out the 2, okay, do my x's cancel out? No, they do not. So what I want to do is I actually want on this top, okay, if I could make this a minus 8, right, then my x's would cancel out. Well, do I want to make it a minus 8? If you want it, then make it happen. Make this a minus 8. Well, if you subtract 8, you also need to add 8, right? So let me look at this. Maybe I can change this. I'm going to group the negative 8 together with the 2x, all right? So I'm going to change this to 2x minus 8 over x squared minus 8x plus 41 plus, what I have left over is 2 and 8, so that's going to be plus 10 over x squared minus 8x plus 41, and that's a dx. All right, if I add these two fractions together, will it give me 2x plus 2 on the top? Yes, it does, because minus 8 plus 10 is 2. So this is equivalent to this original problem right here. And so what I did was I thought I got to do one problem, but oh boy, I get to do two integrals. And if I do both of these integrals and it works out, then I just add the answers together. It's a buy one, get one free problem. All right, so let's look at this left side. On this left side, if I make u equal to x squared minus 8x plus 41, the derivative will be 2x minus 8. Dx would be du over 2x minus 8. I replace two things. I replace the dx and I replace my u. So what I get is 2x minus 8 over u times du over 2x minus 8. Do my x's cancel out? This is an integral. Do my x's cancel out? Why, yes, they do. So I end up with du over u, and this should be an easy reverse power rule, or it should be something on my pink sheet. It is something on my pink sheet. That answer is ln of u plus c, and that's a great answer. It's just the wrong answer. You need to go in and change this u to x squared minus 8x plus 41. And that's the answer to my left side. Let's look at my right side. My right side, if I make u equal to x squared minus 8x plus 41, I take du dx and get 2x minus 8, and I substitute in, okay, I substitute the dx, and I substitute my u. Will my x's cancel out? No. So what I need to do is think of something else. And that something else is, let me complete the square down here. And this could change possibly to an arctangent. If my x's cancel out, then this problem will work out. So let's try this. If I do completing the square here, okay, what I want to do is get a magic number here. What is this magic number? If I divide by 2 and square it, I'll get 16. Magic numbers are always positive. If I add 16, I better remember to subtract 16. Remember, completing the square only works if the coefficient in front of your x squared is a 1, and this coefficient is a 1, so that was not a problem. When I complete the square, the whole purpose to completing the square is so that I can actually get a perfect squared here, and I absolutely do. So I can rewrite this problem as 10 over the quantity x minus 4 squared plus 25 dx. And this problem might be an arctan problem. Okay, if it is an arctan problem, okay, it's got to be a u squared here plus an a squared here, and it looks like it might work. Okay, so let me go ahead and write what I think u squared is. U squared would have to be x minus 4 squared, so u is x minus 4. A squared would have to be 25, so a has to be 5. And if I take the derivative here, just like a u substitution problem, I'd get dx is equal to du. And so I substitute in and I make sure my x's cancel out. And if they do, then it would be an arctan problem. If they don't, then back to the drawing board. So let me go ahead and plug in two things. I'm going to plug in my dx. I'm also going to plug in my u, but in these arctan, arcsecant, arcsine problems, my u is actually u squared here. So let me go ahead and replug this in. This will be 10 over u squared plus 25 times du. Now, at this point, I have to ask myself the question, do my x's cancel out? Yes, they do. There are no x's here, so even better than canceling out. There are no x's to begin with, okay? You want to get rid of all your x's. And then I have to look at it and say, is this something that is an easy reverse power rule problem or on my pink sheet? It is on my pink sheet, except for this 10 up here, okay? So what I do is I rewrite it with the 10 scalar taken out, okay? And this should be something on my pink sheet. Granted, your a squared and u squared might be switched. Granted, this says a squared on your pink sheet rather than 25, but a squared is just some number. So this does match the arctan integral. So the answer to this would be 10 times 1 over a arctangent u over a plus Charlie. And at this point, I just go back and replace my a and my u's. So here I got a is 5. I know u is x minus 4. Okay, so I can rewrite this whole problem. The answer is going to be the answer to the left side plus the answer to the right side. So that's going to be ln of x squared minus 8x plus 41 absolute value plus 10 divided by 5 is 2 arctangent x minus 4 over 5 plus c. And that is your solution. Okay, please make sure that you can do this for your homework. Make sure you can do it for your quiz on Monday. And make sure you can do it for your test in about a week and 2 days or a week and 3 days. All right? All right. Okay, Charles, you're awake? All right, what's the integral of cosine u? What's the integral of cosine u? Sine u, right? So I'll just write sine of 4x. Then I take this u and I say, what's the derivative of u? What's the derivative of 4x? 4. So I divide whatever is left over by 4. Do my x's cancel out? Yes. As a matter of fact, 4 over 4 cancel to 1, too. So I just put that number there, and I really didn't have to. And there's my answer. And if I wanted to check it, I could just take the derivative of sine 4x, and hopefully the derivative of sine 4x is 4 cosine 4x. I could double check that. Okay. It's an integral of x minus 4 over x squared minus 8x plus 1 dx. All right. Guys, always try u substitution first, all right? So I'm going to make my u equal to x squared minus 8x plus 1. It's not the whole denominator. Since it's not the whole denominator, it's not an ln problem. I just want to warn you. It is in the denominator, but it's not the whole denominator. So my du dx is going to be 2x minus 8. So my dx will be du over 2x minus 8, okay? Then I plug in two things. What two things do I plug in? My u, which is right there, and my what? My dx, which is right there. Then I ask myself the question, do my x's cancel out? Do they cancel out? They actually do. Yes, it's not real obvious, okay? But my x's do cancel out, because what I have here is du over 2 times x minus 4. And so since my x's cancel out, this new problem, let me pull out the scalar 1/2, is du over the square root of u. And I ask myself, is this an easy reverse power rule problem, or is it something on my pink sheet? It is an easy reverse power rule problem. I mean, I know it's not super easy, but you have to rewrite this to u to the negative 1/2 du, and I'll let you guys go from there. Okay? Let's look at number 16. 16 was the integral from 0 to 3 of x squared minus 5 over x plus 2 dx. All right. Do you guys notice that you have to long divide here? You guys good with that? Because you got a 2 here, And the biggest power is 2 here, the biggest power is 1 here. So you're going to have to long divide. You could actually split it up into 2 problems also. But when you split it up into 2 problems, you still have to long divide. You can't get away from long dividing. So just FYI, you could do it, you'll see. All right, so what I have here is x plus 2. Just to make it a little bit easier, I'm going to put in a placeholder here. So plus 0x minus 5. Okay, just to make it a little bit easier. All right, x times what gives me x squared? X. Okay, so I'm going to put an x there. X times x plus 2 is going to be x squared plus 2x. All right? X squared minus x squared is 0. Everybody good with that? 0 minus 2x is minus 2x. Okay? You're going to carry down the negative 5 and do the same thing. X times what gives you negative 2x? Negative 2. Minus 2 times x plus 2, basically distribute, is going to be minus 2x minus 4. Okay? Negative 2x minus 2x is 0. The first term should always be 0 because you match them up. Negative 5 minus negative 4 is what? Negative 1. Okay, so what you get is plus minus 1 over x plus 2. Okay, so my new problem is going to be x minus 2 plus negative 1 over x plus 2 dx. So you thought you got to do 1 problem, but, oh boy, you get to do 3, okay? So let's do the first one. The first one's just x squared over 2, right? What's the integral of 2? 2x, right? What's the integral of negative 1 over x plus 2? Negative ln of x plus 2 plus c. Okay, just to make sure you understand how to do this, you make your u equal to this. The derivative of x plus 2 is 1. You divide whatever you have left by 1. And so that's your scalar in the front. If your entire bottom was your u, then that's an ln problem. Okay, as long as your x's canceled out, which they did. There were no x's. Okay, and so this is my answer. And so once I get the answer, I don't need the c anymore because I'm going to put in some limits here, 0 to 3. Okay, so first you plug in the 3, that's 9 over 2 minus 6 minus ln of 5, right? Then you plug in the 0, that's 0 minus ln of 2. Then you slap a minus sign in between. So this becomes 4.5 minus 6 minus 1.5 minus ln of 5 plus ln of 2. This one, remember 1 log fraction equals 2 log subtraction. So this one is actually, okay, there's the 2 log subtraction. So the 1 log fraction is going to be, if I did this right. Someone check me on this. Does anybody know the answer? That's right. Thank you. All right. Any questions on how to do this one? This is the product rule of integration. Okay, we said there was no product rule of integration. Well, I lied. So this is the product rule of integration. Okay, and the formula is this, and you have to memorize this formula. So can you go pull out your pink sheet, please? And on your pink sheet, near where it says calculus BC, like the calculus BC part, okay, you have this formula for integration by parts, and it looks like this. It looks like integral of u dv equals uv minus the integral of v du. Okay? And you're going to memorize this formula. Okay? Now, it looks terrible, but you're going to practice this so much, okay, that this will not be the terrible part. Okay? So you're going to memorize this. And I'm going to show you guys where this comes from. You don't need to know where this comes from. I'm just going to show it to you guys so that I can convince you guys that I'm not making it up. Okay? If you set y equal to uv, y is just some random function y, okay? And you take the derivative of both sides. So what I'm going to do is I'm going to do the d dx of both sides. What I'll get on the left side is dy dx, okay? What I'll get on the right side is the derivative of the first times the second plus the derivative of the second times the first, all right? Once I get that, what I'm going to do is multiply everything by dx. And the nice thing about LIPET notation was that algebra worked with it. Okay, so I'm going to multiply everything with dx by dx. And so I get dy is equal to v du plus u dv. And you can see my formula starting to take shape. All right. And then the next thing I'm going to do is I'm going to integrate both sides. Okay, so I'm going to go ahead and integrate both sides. And the integral of dy, okay, actually this is 1. So the integral of 1 with respect to y is actually just y. Okay, so on the left side I have y plus c is equal to the integral of v du plus the integral of u dv. All right, but what is y really? What is y? uv. Okay, so I'm going to go in here, I'm going to replace y with uv. Okay, I'm going to solve for u dv, so that means the integral of u dv is equal to uv minus v du, and then I have a Charlie, some Charlie. Okay, and at the end we'll just add Charlie. So when you do the formula, we don't actually talk about Charlie, but you just add Charlie at the very end when you're done. Okay, and this is the formula for integration by parts. So let me show you how it's done, or why it's done. Okay, so on your test, remember, I don't tell you what method to use, and that's the tough part. And so what you always want to try is use substitution first, okay? If I look at this problem, do you see, if this is my sine u, what's the integral of sine u? What's the integral of sine u? Is it negative? Negative cosine u, okay? And then this is the u. So what's the derivative of x squared? 2x. So if I divide by 2x, do my x's cancel out? Yes. So what I get here is this answer, if I integrate it, is negative 1/2 cosine x squared plus c. And that's kind of a shortcut. If you weren't comfortable with that, you could have done it the long way. U equals x squared, du dx equals 2x, dx equals du over 2x. And you would have ended up with the same thing. You substitute your u and your dx. So this would be x sine u du over 2x. And this would, the x's would cancel out. So this would be 1/2 integral of sine u du. And I should get the same answer there. Okay, I'll let you finish that up. Okay. Now, what if I had given you this problem? Let's look at this problem. What's the integral of sine u? Negative cosine u, right? What's the derivative of x? 1. Divide by 1. Do my x's cancel out? Okay. This is not a u-sub problem. Okay. This was a u-sub problem. This is not a u-sub problem. It turns out this is an integration by parts problem. But again, on your test, there's like a trick. It's not really a trick. It's just that you think everything is an integration by parts problem. But always try u substitution first. Everybody good with that? If that works, don't go to integration by parts. Don't go to arc sine. Okay. You want to test the u substitution first. You have to write LIPET on the top of your worksheet, please. LIPET. That's an acronym you need to know. Okay. It's the order in which we put our letters for integration by parts. The L stands for log. An example of log is just like ln of x, ln of 2x, okay, ln of x squared. Okay, that's log. Inverse trig, okay, what inverse trig is like your arc sines and your arc cosine or whatever. So arc sine, arc tangent, arc secant, okay, those are your inverse trigs, okay. The P stands for polynomials. Polynomials are easy, like x, x squared, okay, 5x, okay, those are polynomials, okay. Your E stands for exponential, so that's like e to the x, okay, or e to the 5x, all right. And T stands for trig, and trig is not your arc trig. So make sure you understand trig is just your regular sine x or cosine x or tangent x or whatever it is. Okay, that's your trig. All right, so remember that in order, and let's work the first problem. Okay. So what you do when you try use substitution first and it doesn't work out. So first, make sure you try use substitution and it doesn't work out. What you do is you define your u and your dv. Okay, remember that integration by parts says the integral of u dv equals u times v minus the integral of v du. So all I'm going to do is I'm going to define this as u and dv. Okay, so I'm going to make my x u, and I'm going to make this whole cosine x dx my dv. All right, and then what I'm going to do is I'm going to substitute right into this formula. Okay, so you make a little cross. Here, I have a cross here already. You make a little cross. Okay, you're gonna put something in each of these quadrants. All right. Your top left, you're gonna put in your u. So you put u equals x. Your bottom right, you're gonna put in your dv. So you're gonna say dv equals cosine x dx. On the left, you're going to take the derivative. du dx of x is 1. But actually, du dx isn't very useful to us. We really just want du. So what I'm going to do is cross multiply and solve for du. And so du actually turns out to just be 1 dx. You can put that 1 or not, depends what you want to do. All right, so this is not useful, but I solve for du. On the right side, I'm going to take the antiderivative. So this over here was the derivative. This is going to be the antiderivative. So if you think about what I'm doing, I'm really just taking the antiderivative of both sides. Okay? What is the antiderivative of 1 dv? It's just v. V plus c. But we're going to ignore all the plus c's, because when we're done, we'll just throw in a plus c. Okay? What is the antiderivative of cosine x? Sine x. Okay? And don't worry about the plus c. Okay, you guys good so far? All I'm going to do is plug right this formula using this legend that I've made. I know what u is, and I know what v is. Here's u and v right here. So u times v is going to be x times sine x minus. Minus what? Minus the integral of v du. Well, here's my v, and here's my du. So I'm going to multiply these two together. So this turns out to be the integral of sine x dx. You guys see how all I did was just a substitution. Like I memorized the formula and I substituted right into it. So what this tells me is that the integral of x cosine x dx, integral of u dv is equal to x sine x minus, guys, what's the integral of sine x dx? Negative cosine x, right, plus Charlie. I'll throw in Charlie at the end, don't worry about it. And so this answer is x sine x plus cosine x plus Charlie. And I've done integration by parts. Good. Just memorize the formula and throw it in. Now, where did the LIPET come in? L-I-P-E-T. Do you agree that this could have been written as the integral of cosine x times x dx, right? And then I would have made my u and my dv something different, okay? So the LIPET helps you determine what's your u and what's your dv. The x is actually a polynomial. The cosine x is actually a trig function. So this is your p and this is your t. So whatever order this is, that's your u and that's your dv. So had you had it in this order, this would have been your t and this would have been your p. So you need to switch it before you get started. Does that make sense? So LIPET tells you what order to do the u dv in. If you do it in the wrong order, sometimes it's fine. Sometimes it's terrible. Okay, so I'm just letting you know. It sometimes works if you don't do it right, but in the right order. But it sometimes just absolutely does not work at all. Okay? All right, let's do this second example. If you remember long ago, I told you that this integral wasn't on your pink sheet. Like you think it's on your pink sheet, but it's actually not. You can look for it for a long time. You won't find it, especially those of you who have lost your pink sheet, you won't find it, okay? But this is actually a LIPET problem. It's actually an integration by parts problem, okay? What it is this is actually your u, and this is actually your dv. Kind of weird. But your dv doesn't have anything attached to it but this dx. If you want something attached, it's 1 dx, okay, if you want it to have a number, okay? And this is how you do this problem, okay? You do that little crosshairs, just like we always do for integration by parts. On the top left, you put your u equals. So u equals ln of x. On the bottom right, you're going to put dv equals dx. Okay, make sure you know I have notes for you guys. So you should just be working in your notes. Okay. Yesterday or last period, somebody was like, "What? This is all in my, this is all written down." I was like, "Yeah, actually it was." Okay. So right here, the left side, you're going to take the derivative. So the derivative du dx is equal to, what's the derivative of ln of x? 1 over x, right? Okay, but again, guys, this du dx isn't useful to me. I really want du. So I'm going to solve for du, and du is actually 1 over x dx. Okay, so you're going to use cross-multiplying, whatever you need to do, but you need to solve for du. Okay, so this is not useful. I'm going to use this part down here. Right here, I'm going to take the integral of both sides, okay, on my right side. So the integral of dv is v. The integral of 1 dx, what's the integral of 1 dx? It's just x, so v equals x. All right, so I've done my crosshairs, and I'm just going to plug right into the formula. This formula says the integral of u dv equals u times v minus the integral of v du. So u times v is just these two multiplied together. So that's just x ln of x. You guys good with that? I mean, you could say ln of x times x, but it's a little bit awkward. So I just say x times ln of x. All right, then the integral of v du, so that's the integral of v. What's v? v is x. Okay, what's du? du is 1 over x dx. Okay, what is x times 1 over x? What is x times 1 over x? It's just 1. Okay, what is the integral of 1? So this becomes minus x plus Charlie. Don't forget Charlie. Okay, and there's your answer. And this is common enough that some students just memorize this, because eventually we get a lot of this and students just memorize it. But it is using integration by parts that we get the answer. Skip the third example. Let's go to the fourth example. You guys can go back to the third example on your own, and we can do it also if we have time. Okay, so let's look at this problem. First of all, definitely try u substitution, okay? But if you try it, I'm just going to let you know it doesn't work, okay? Not really sure how to make it work. And so what you're going to do is you're going to define your u. Well, actually, you have to figure out which one's u and which one's dv. So this is a polynomial. This right here is an ln problem, right? Think about LIPET. Which one goes first, the L or the P? The L. Okay, so you need to switch this. Okay, so this problem is ln of x times x squared dx. If you don't switch it, if you define the u incorrectly, this problem is going to blow up. It's not even going to work. Okay, so therefore this is my u and this is my dv. Okay, remember the integral of u dv is equal to uv minus the integral of v du. So let me go do my crosshairs. Okay, fill in my quadrants. So u is equal to ln of x and dv is equal to x squared dx. What is the derivative of ln of x? 1 over x. So guys, I'm just letting you know, from here on out, I'm just going to move the dx to this side, because that's basically how you do it. Okay, I'm going to skip that little step where I go du over dx. Okay? On this side, what is the integral? I know the integral of dv is v. What's the integral of x squared? X cubed over 3. And of course, there's a Charlie, but we're going to ignore Charlie for now. Then what I'm going to do is I'm just going to plug right into this formula. U times v is going to be ln of x times x cubed over 3. Actually, let me switch it, because I don't want to accidentally move that x cubed over 3 into the ln of x. So it's x cubed over 3 times ln of x minus the integral of v times du. So that's going to be x cubed over 3 times 1 over x dx. Okay, you guys with me so far? All right. The uv doesn't change. I'm already done with this first term. What's x cubed divided by x? X squared. Okay. So there's my new integral over here. Guys, can you do this integral? What is the integral of x squared over 3? Is it x cubed over 9, right? And don't forget Charlie, and I'm done with this problem. What are you thinking? Is it bad? It's not terrible, right? Okay, let me show you terrible. Okay, let's do this problem. Okay, what letters is this one going to be? So let's make sure we have it in order. What letters is this one going to be? E, T. Oh, cool. E-T. Okay. So we have an E-T. Is it in the right order? Like it. Yes, it's in the right order. So this is going to be my U, and this is going to be my dV. Okay. Remember, this is equal to UV minus the integral of V du. Okay. I'm going to go ahead and make crosshairs here. On my top left, this is U equals EX. On my bottom right, this is dV equals sine X dx. Okay. What is the derivative of U? du equals EX dx, right? What is the integral of sine X? V equals, I think it's negative cosine X. Are you good with that? All right, I'm going to go ahead and plug in. So this is U times V. So U times V is negative EX cosine X minus minus what? Minus the integral of these two multiplied together, v du. So that's going to be minus negative cosine x ex dx. Okay. Do you agree? This is a minus minus. So if I pulled out this negative scalar, this would be plus plus. Right? And so the problem is negative ex cosine x plus, and I'm going to switch this ex, because this is a e and this is a t, right? So I'm going to switch it, ex cosine x dx. I'm just rewriting the problem, really. Okay? Can I do this by hand? Can I do this with u substitution right here? No. But you notice that it's a what type of problem? An ET problem. So what do? You do it again. Okay? So we're going to do it again. So here we go. Okay? So let's make sure we understand. This term is already done. So this negative ex cosine x is already done. I'm going to add it with whatever this answer is. Everybody good with that? I'm going to add it with this answer, whatever it is. Okay? And this right here is going to be uv minus v du of whatever this is here. Okay? So now my u is ex, so u equals ex. My dv now is cosine x dx. All right. So what is the derivative of ex? du equals ex dx. What is the antiderivative of cosine x? Sine x. Do I have a negative or not? An antiderivative. No negative. Okay? Then I'm going to plug right into this formula. So let me rewrite this. This is going to be negative ex cosine x. That term was already done. Plus what? Plus u times v. Okay, so right here, this is ex sine x minus what? V times du, okay? So that's going to be ex sine x dx, okay? And that's what's going to go inside these brackets. Okay, so let me think about what I need to do. I need to figure out what the integral of e to the x sine x is. Okay, what kind of problem is that? Et. But guys, wasn't this my original problem to begin with? So if I keep doing it, what's going to happen? I'm going to keep cycling through, right? Okay, I want to write something for you. Do you see this left side right here? Isn't that equal to this right here? Okay, let me write it for you. Maybe you'll see something. Ex sine x dx, right? That is equal to, I'm going to write this whole right side. That is equal to negative ex cosine x plus ex sine x minus the integral of ex sine x dx. Do you agree that that's right? All I did was write the left side and make it equal to the right side. What is my goal? What am I trying to do? I'm trying to solve for the integral of ex sine x, right? Guys, look at this down here. Can I solve for the integral of ex sine x? You guys see? My goal is to find what the integral of ex sine x is. Right here in this equation, can I find what the integral of ex sine x is? Check this out, guys. All I do, okay, because on all these ET problems, you're going to end up matching something. This is the exact same thing as this. What I'm going to do is use algebra and take this thing home, okay? So, guys, if I take this home, think of what's going to happen. I'm going to add this to both sides. So I'm going to add integral of e to the x sine x dx to this side. Add integral of e to the x sine x dx on this side. What will I get on the left side then? 2ex sine x dx is equal to negative ex cosine x plus ex sine x. All right? Remember, don't lose sight of your goal. What was my goal? To solve for the integral of ex sine x dx. Can I solve for it? You can. The integral of ex sine x dx is equal to negative ex cosine x plus ex sine x, all divided by 2, and that is your answer. Oh, don't forget, what did I forget? Don't forget Charlie. Okay, and that is your answer. So guys, whenever you have an ET problem, what's going to happen is ET will go home. Do you guys see that? Okay, ET will go home. Whenever you have an ET problem, you know you're going to have to cycle it, and eventually when you get the same thing, take him home. Okay? All right, let's do our last problem here. example 6. I think this is all we're going to have time for, and I think you'll be okay after this. All right. PT. You guys okay, PT? Is it in the right order? Okay. If it's in the right order, then because LIPET, right? LIPET. This right here will be my U, and this right here will be my dV. Okay, so make sure we're in the right order, and we are. Okay, this is going to be equal to UV minus V du. Okay, the first thing I'm going to do is I'm going to write my U in the top left, and I'm going to write my dV in the bottom right. Okay, on the left side, I'm going to take the derivative. So du equals the derivative of x squared is 2x. So du equals 2x dx. On the right side, I'm going to take the integral. The integral of cosine 4x is 1/4 sine 4x. Hopefully you're with me on that. I'm doing it in my head. Okay, but the integral of cosine 4x is sine 4x divided by 4. Okay, I'm going to go ahead and plug into this formula. U times V is going to be 1/4 x squared sine 4x. Okay, that's just my top two quadrants multiplied by each other. Minus the integral of V du, okay, when I multiply 2x times 1/4, it's going to be 2x over 4 sine 4x dx. Guys, with me on that. The 2 over 4 can change to what? This could be a 1/2, right? Everybody good with that? Okay, so what I'm going to have is 1/4 x squared sine 4x minus the integral of 1/2 x sine 4x dx. All right, if I take this sine u, the integral of sine u is cosine, negative cosine 4x. The derivative of 4x is 4. When I divide by 4 here, do my x's cancel out? No. So you have to actually use integration by parts again. So this is going to be p, it's a polynomial, this 1/2 x, and this is going to be t. Okay, now don't get intimidated, we've done this already. This is going to be my u, and this is going to be my dv. Okay, so when I'm done, 1/4 x squared sine 4x, this term's already done, this 1/4 x squared sine 4x. I'm going to subtract it by everything in this bracket, right? I'm going to subtract it by whatever this uv minus v du is. Is everybody good with what I'm about to do? Okay, so let me go do uv dv on this problem. So I'm going to make the crosshairs. On my top left, I have u equals 1/2 x. On my bottom, I have dv equals sine 4x dx. Okay? The derivative of u is going to be 1/2 dx. So du 1/2 dx. The integral of sine 4x is negative 1/4 cosine 4x. I'm doing that in my head. Remember we talked about you need to be able to do this in your head. Okay? So let me transfer that over to this big bracket I have here. Okay? So inside this bracket, it's going to be u times v. Do you see that's negative 1/8 cosine 4, oh no, x cosine 4x. Negative 1/8 x cosine 4x. Everybody good with that? Minus the integral of these two multiplied together, the v du. So that's minus 1/8 cosine 4x dx. Okay? Negative 1/8 cosine 4x dx. That I can actually do in my head. Okay, so let me rewrite this whole right side. What I have is negative 1/4 x squared sine 4x minus negative 1/8 x cosine 4x. Okay, do you see this as a negative negative? I'm going to change that to a positive. The integral of cosine 4x is going to be sine 4x, and this will be plus 1/32 divided by 4. You guys good so far? I know I'm going fast, but I wanted to finish this. Good so far? Okay, this is my answer, guys. The only thing I need to do is distribute this negative. Okay, so my answer is 1/4 x squared sine 4x plus 1/8 x cosine 4x minus 1/32 sine 4x. Okay, don't forget Charlie. And there's my answer. Okay, hopefully we have time. I'm going to do a trick on this one. This was a lot of work. Whenever you have a PT problem or a PE problem, there's a shortcut. Okay, For what type of problems, guys? PT or PE, okay? And guys, I'm going to go ahead and show you guys a shortcut, okay? What you do, guys, first you verify that's a PT or PE. Guys, write that somewhere down because students will do it on all sorts of problems. You can only use this trick. It's called the table trick, okay? On a PT problem or a PE problem. You put the U on this side and you put the dV on that side, but don't use the dx. You just put the different expressions, okay? On the left side, we're going to take the derivative all the way down until you get to 0. This is always a polynomial, so it'll eventually get to 0. Okay? On the right side, you take the antiderivative and just match it up with the left side. So the antiderivative of cosine will be 1/4 sine 4x. The antiderivative of this will be negative 1 over 16 cosine 4x. Remember, we're doing a shortcut, right, of the antiderivative. The antiderivative of this will be negative 1 over 64 sine 4x. Does everybody see what I'm doing? Make sure you can take the antiderivative, though, because had this been a square, the x's wouldn't have canceled out, okay? So you take the antiderivative, then you do these signs alternating, plus, minus, then you draw diagonals, okay? Now what I'm going to do is I'm going to pull my answer up, and I'm going to show you that this shortcut is the same as my answer down here. Okay, unfortunately, I do not know how to get rid of this thing. Okay, so let's see, and you guys have your answer on your paper too, right? Let's see if this is the same answer. This is a shortcut for only PT and PE problems. It's called the table trick, okay? What I'm going to do is multiply and add. X squared times 1/4 sine 4x is my first term. Is it? Okay. Then negative 2x times negative 1 over 16 cosine 4x is my second term. Is it? Yes. Then 2 times negative 1 over 64 times sine 4x is my third term. Is it? Check. Okay. So it's your choice. You can do the table trick, or you can do that whole long thing we did where we did the integration by parts twice. Okay. Remember, this table trick only works for what two types of problems, guys? PT and PE, okay? And that's really all your notes today.